So this last problem here, actually this last set of problems, involves matching a table that you see here. We've got 4 tables, 45, 46, 47, and 48. Each of these tables is going to be represented by one of these graphs down here, A, B. So you have A, let me do that in a different color, A, B, C, and D. A, B, C, and D. So the question is, what kind of information are we getting from f prime and not existing versus existing and being 0? So if we look at what we're going to do here is we're just going to isolate this graph of A down here. So I'm right down here at the graph of A, and we see here that f prime of A does not exist. So maybe I'll do that over here. F prime does not exist at A and at B, and f prime of C, so f prime here would be negative. Okay, and so let's see if we can take that information and apply it to one of these tables up above. And as we can see, that the graph that I just analyzed, and I wanted to just erase this part here. The graph that I just analyzed shows that f prime of A does not exist. Let me see if I can, hold on a second. I'm going to pause the video so I can get a good highlighter. Okay, good. I found what I was looking for. So f prime of A here does not exist. So that's consistent with what we just said. F prime does not exist. F prime at B does not exist. Again, consistent with the graph of A. And then f prime of C, we said that that was less than 0, and that certainly is f prime less than 0 there. So 48 then would be A. Oh, that's a bad number. Hold on. 48 would be A. Let's see what color I can use here. 48 would be A. Okay? So that takes care of 48. Now, let's go ahead and look here at the graph of B, the B graph. We can say with certainty here that f prime of A is equal to 0. Okay. We can also see a horizontal tangent line where f prime of B is equal to 0. And then here, f prime of C, we see a slope of a tangent line at C being negative. So we have f prime equaling 0 at A and B, and then f prime is less than 0 at C. And that only happens at one of these. So we can see for number 46, f prime at A is equal to 0, f prime of B is equal to 0, and f prime of C is negative. And so therefore, problem number 46 would match up, table number 46 would match up with the graph of B. Okay? I should put those in lowercase, but that's going to bug me if I don't, so I will do that. So we have lowercase a and lowercase, oops, sorry I messed up there, and lowercase b. Alright, so again we'll go down here to our graphs and we'll look here at the graph for the C graph, and let's draw a horizontal tangent line there. So we have f prime equaling 0 right here at A, and again we have f prime equaling 0 right there at B, but then over here we have f prime being positive, and I remember seeing one of those. We have 0, 0, and positive. Number 45, look at that. F prime is 0 for A, f prime of B is 0, and f prime of C is positive 5. So therefore, number 45, the table for number 45 matches up with the graph of C, and therefore the table here of number 47 matches up with the graph of D. But let's go ahead and look at D anyway. I know that you guys are probably, most of you are probably already turning off the video, but nevertheless we have a sharp point here. That's where f prime does not exist, and D and E. We have f prime equaling 0 right there at B, and then here a tangent line would have a negative slope right there at C, so we would have f prime is less than 0 there. and so then that would match up with f prime of A does not exist, f prime of B equals 0, and f prime of C would be a negative value, and so there we have it. So 45 through 48, those are fun problems because there's really very little work involved, but a lot of understanding that needs to happen in order for you to be successful in those problems. So I hope you had a successful time on page 184 and 185, and I will see you in class.